I'm Chun from China. I'm actually working in AI platform team, and I'm the program manager of Anomaly Detector. In our previous AI shows, we have talked about Anomaly Detector on the cloud and Anomaly Detector on-prem as containers. Now you know that both of them are available to you, but now I'm going to introduce to you some more interesting tips. Actually, 3 tips to help you build your anomaly detection solution that's going to be used in production. OK, we are going to start with the first step. It's batch versus streaming. So Anomaly Detector APIs, we have provided 2 functionalities, or endpoints, namely entire /entire for batch scenarios, and /last for streaming scenarios, respectively. So when you want to detect all anomalies, every anomaly from the entire data set that you send in a single API call, a single HTTP call, /entire is what you need, as it will create a single statistical model and apply that to every measure point in the data set. On the other hand, when you want to detect anomalies from a stream of data, /last is recommended, as it returns only when the last data point, whether the last data point in your request is anomalous or not. So in general, entire is for batch and last is for streaming. However, /entire is a bit slower than /last. So customers would prefer to use the /entire in the cases when latency in seconds is not an issue. For example, historical data analysis, or you want to take an overview, preview the data set, what the pattern of the data is. Or there are some business KPIs with really large granularity, like hours, days, or even weeks. You can go with /entire, and it will tell you all anomalies. Now, /last is more suitable for real-time monitoring cases. For example, IoT metrics, or cases when the data is in a streaming fashion, although latency is not a concern. For example, business metrics in production that constantly updates with new data points. So that is still streaming data, but it's not in the fine granularity like some IoT data. So anyway, those are all suitable for the /last API. And I'm going to show you some examples. So these are the examples of the endpoints, because the service so far is still in public preview as we speak. And we will host the service and the API service on more Azure regions. But now you have West US 2 and West EU, West Europe. And these are really the different endpoints for those Azure regions. As you can see in the table, I've highlighted the /entire and the /last. Now, when more Azure regions will come, and the endpoint for the region will change. Apart from those Azure regions, we also have containers, right? So with containers, you are able to spin up the anomaly detector containers with a local host IP address. It could be your local host or a host that's sitting side by side with your production environment. So anyway, you get an API endpoint with your local host address. And the rest of the URL just resemble the cloud endpoint. Yeah, so that's it. That's the first tip. The /last versus the /entire. /entire for the batch scenario, while the /last is for the streaming scenario. That's pretty straightforward, right? Now let's go to the second tip. This is about streaming. We have the last /last endpoint, and that is designed exactly for streaming scenarios, no matter where your streaming data is coming from, event hubs, IoT hub, or Kafka. You can write code to load your data in sliding windows and send over HTTP requests to Anomaly Detector APIs to detect anomalies in a streaming fashion. However, from time to time, some developers who start to code with Anomaly Detector APIs get really confused about the /last API. And they will find it a bit difficult to connect the API with a streaming data source. So in order to build a streaming anomaly detection solution with Anomaly Detector, developers and architects, you really need to keep two important things in mind. Firstly, it's about the caller. Because with the service as REST APIs, what you need is really an application that's played the role as caller to load, to cache, and to prepare the time series data and make the HTTP calls with the data that you prepared. This application could be written with, implemented with .NET, Python, so basically any programming language that can load data from your streaming source, event hub, etc., and make an HTTP call. And the compute infrastructure for your application, for your caller application, for your data prep application could be Azure Notebooks, Jupyter Notebooks, or Azure Databricks, or Azure Functions, or even some infrastructure as a service solution on your on-prem infrastructure. And also Power BI, I'd like to highlight this. Power BI can also do this. So I mean, Power BI is not only a visualization tool. It can actually call Anomaly Detector APIs with customized queries. The second thing that you'd like to keep in mind is about sliding window. So it's basically a part of the data preparation. Because I'd like to mention one thing here is, in the previous slide, you see the endpoint, there's 1.0, which means this is the first version. This is 1.0 version of the APIs. And this version is stateless. It means every API request is independent from each other. So if you call the API with your data, and then you make a second call, there's no correlation between the two API calls. With that, the /last API requires a window of data points from your request. It runs detection only on that data set that you send over each individual request. You cannot send over only one single data point, even if you have already sent over a lot of data in prior to that. Therefore, you need to create a sliding window over your streaming data and move the sliding window as new data streams in. And the sliding window could be sent over the API endpoint over HTTP at the same cadence with your data granularity. I'm going to show you a really cool and interesting demo that's going to explain much better about how this works, the sliding window works. This is basically a demo that you can access from internet, ak.ms AD demo, and you will be able to play with it. Now, the first thing that you need to grab from Azure portal is the API key and an endpoint. So if you create your anomaly detector resource on West US, you have this. Otherwise, there's West EU. And input your key, the anomaly detector resource here. Now you are ready to play with it. We can actually play with this sample. So this is the last API. It's about streaming. Now I'm going to run it first. As you can see, on the right side, in the current request input, there's the data that's being sent over HTTP. And on the left side, there's this gray shade, which is moving. This is my favorite part. It is the window, the sliding window of the data that's being sent over HTTP to the API endpoint. And the response that's on the bottom of the right side is basically telling you whether the last data point in this API call is anomalous or not, together with something like upper margin, lower margin. You can play with it, tune the sensitivity, and change the max detecting window. It will actually change the size of the shade. So this is really intuitive, and will show you how streaming works with Anomaly Detector API, the /last API. Let's dive into the code. Here's some snippet of Python code that gives you an overview of how to create such an application. As you can see, the second function, the stream detection function, it really creates a sliding window with maximum size at this predefined sliding window size. So this is predefined. And then call the other function, detect last, which will call the endpoint /last endpoint to detect anomaly. And back to this function, you will see a loop here. This loop is how you build a demo. I mean, it moves the sliding window from left to right. In production applications, in real life, what you want to do is implement something really like a scheduled job to move the side window instead of just a loop, right? Because it should move when new data streams in your data granularity. On the right side, this is output that you also see in the previous demo. Now the remaining question is, how do we actually determine the number of data points that we should send over to the API endpoint over one single HTTP request? In the streaming case, what is the best sliding window size? In the batch scenarios, how many data points should be sent when your data have different granularity and patterns? We have the third tip is going to address that. Tip number 3, it's about data preparation. Because the performance and accuracy of anomaly detection results really can be impacted by how your data is prepared, how your parameters, although there are only one that you see previously, how that parameter is used, and the number of data points in your API request. So starting with some basic requirements that your API, the Anomaly Detector API, it requires time series data formatted into JSON request object. And the minimum number of data points that it accepts is 12, and the maximum is 8640 points. And your data point that's sent over to the API must have a valid UTC timestamp and a numerical value. And that defines a time series. Then, with the basic requirements met, how to make it work better? If your data is evenly distributed, that's good, because that's what the API needs. If your data is randomly distributed over timeline, as you can see in this slide, this is evenly distributed. And these are the cases when data is not evenly distributed. The left one is like a random distribution, and the right one is more like missing data point. When data is randomly distributed, you should aggregate it by a unit of time, such as per minute, per hour, or daily, so that it will be evenly distributed. If there are missing data points, well, it's common. I mean, there are sometimes missing data points. What you need to do is to have a statistic algorithm here to fill the gaps. I would say normally missing less than 10% of the expected number of data points is not a big issue. It will not have a negative impact on the results. While in other cases, if the missing data points are more than 10%, you can fill the gap based on its characteristics, like substituting data points from an earlier period, or linear interpolation, or maybe a moving average. Anyway, the goal is to make it evenly distributed. Finally, if your data have seasonal patterns, normally we call it seasonality. So if your data has seasonality, which means the pattern actually occurs at regular intervals, like what you see on this chart, you can actually improve the accuracy and the performance. One way to do that is to specify a period. So this is another parameter that's hidden, and you don't normally use it. But with seasonality, you can specify this period parameter when you construct your JSON request. It can actually reduce the latency by up to 50%. This period is basically an integer, and it specifies roughly how many data points the time series takes to repeat a pattern. Let me give you an example. If you have time series data with weekly pattern and 1 data point per day, so it means 7 data points per week, and the seasonality occurs every week, then the period could be specified as 7. If the weekly pattern is with some time series with like 1 point per hour, then you want to have your period as 7 by 24. This parameter is actually optional. So if you're unsure of the data patterns, unsure about the seasonality, you don't have to specify it. Another practice here for best results is you can provide, actually, if you provide 4 periods worth of data points plus an additional 1, that it will make the API work better with better accuracy. For example, if you have hourly data with weekly pattern, as described previously, you could provide 673 data points in your request body, so which is 7 by 24 by 4 plus 1 extra data point. That's it. That's the 3 tips and of using Anomaly Detector. If you want to build a production environment, you may want to check that out. Also, with Anomaly Detector shipped as an API service, we have these quick links for you. So firstly, go to ak.ms Anomaly Detector or search on Bing to check out the overview of the API service. Or you can join our community where there are our engineering group, as well as other customers and the Microsoft partners and the Microsoft teams by going to ak.ms AD advisors join. And to get the containers, you can go to ak.ms/AD container to apply for the container credentials. Thank you for watching.